Hello and welcome to a new video of NG Smart Classes. This will be the fastest crash course that ever exists in sheet metal drawing operation. Believe me, it is, because here we will not be wasting any time in studying useless things that doesn't play any important role here. Okay, without wasting any time, let's proceed. What will happen in case of sheet metal drawing operation? Okay, let me pick a pen first. Pens. Okay. The first topic will be, okay, so today's topic is sheet metal drawing. So what is a sheet metal drawing operation? In case of sheet metal drawing operation, what will happen is that we'll be having a blank. Initially we'll be having a blank. Let's say the diameter of the blank is D and the thickness of the blank is T. The thickness of the blank is T. In case of sheet metal drawing operation, this flat blank of diameter D and thickness T will be converted into a 3D product. Let's say a shell or a cup. It's a 2D sheet and it will be converted into a 3D product. It will get converted into a 3D product. The diameter of the new product that will be produced is D. The height is, let's say, H. Height is, let's say, H. This much is not. This is the thickness. This is the thickness, which is this is the thickness of the new product that has been produced. This will be a 3D product. This might be a cup or a shell, whatever. Okay, so the most important thing in sheet metal operation is that what will be the diameter of the blank. Okay, we'll be given that a cup or a shell is produced, which will be having a diameter D, height H, thickness T, height H, thickness T, and diameter of the product that will be produced will be given. Will be asked to find the diameter of the blank. So here the diameter of the blank will be capital D is equal to under root of D square plus 4 DH. D square plus 4 DH. But however, this formula will be valid only when small d is greater than 20R. And believe me, in most of the cases small d will be greater than 20R. But however, you should check it. Here R, here what is R actually? Here R is corner radius. Corner radius, that is, here at the corners some radius of curvature will be achieved. That is the corner. Here sharp corners will not be obtained. Here some radius of curvature will be there, and this will be the corner radius. This will be the corner radius. Okay, now let's say there is a case where the diameter of the product that has been produced is greater than that of 15R but less than that of 20R. What will happen in that particular case? In that particular case, diameter will be, diameter of the punch will be D is equal to D square plus 4DH minus 0.5 R. But what will happen here is that when we will produce a 3D product out of the sheet material, in the upper region there will be some extra part produced. This is the extra part. This we need to trim out. This part we need to trim out. So we need to provide some trim allowance if it is mentioned in the question. Otherwise we don't need to provide it or include it. If it is given in the question that we need to provide this amount of trim allowance, then we'll have to include it. So the diameter of the punch will be D is equal to, what will happen, it will be d square plus 4dh plus trim allowance if d is greater than that of 20R. On the other hand, d is equal to under root of d square plus 4dh minus 0.5R plus trim allowance if d is greater than that of 15R but less than that of 20R. Okay. Now one most important defect that is witnessed in case of sheet metal drawing operation is, okay, let me draw first for better understanding. Okay, so what will happen, the final product that will be obtained, let's say this is the final product, this particular region is called as the flange region and this is called as the top. So what will happen here, mainly two types of defects are witnessed in case of this sheet metal drawing operation. Now we know that the blank must be held firmly with the help of blank holders and there will be a punch. Let's say this is the die. Okay, these are the blank holders. These are blank holders. These are blank holders. So there will be some blank holding force. Okay, now if the blank holding force is too high, blank holding force is too high, then what will happen? Then there will be a fracture in the flange region. There will be fracture in the flange region. There will be a fracture in the flange region. Okay, now again, if the blank holding force is too low, then what will happen? If the blank holding force is too low, we will witness wrinkles in the top region. Wrinkles. Why will we witness wrinkles? For this, we will have to understand what stresses will be acting in the final product that will be produced. Let's say this is the final product that has been produced. Now in the flange region, only tensile stresses will be acting. This is the flange region. Here only tensile stresses will be acting. And in the top region, what will be acting? In the top region, compressive hoop stresses will be acting. Compressive hoop stresses will be acting. So what will happen? What will happen is that if the compressive hoop stresses are too high, then it will produce wrinkles. It will produce wrinkles in the top region. So in order to prevent compressive hoop stresses, the blank holding force must be increased. So what we understood from here is that if the blank holding force is too low, then due to the compressive hoop stresses, wrinkles will be produced in the top region. So the blank holding force should be increased. Again, if we increase the blank holding force too much, then fracture will be produced in the flange region. So the blank holding force must be optimum. Blank holding force must be optimum. Now in case of sheet metal drawing operation, what stresses will be acting in the final product? Both tensile and compressive. Both tensile plus compressive stresses will be acting. Both tensile plus compressive stresses might be acting. This might be asked in various competitive exams. So in case of wire drawing operation, what we obtain, in case of wire drawing, we know that in case of wire drawing, in wire drawing we will have tensile stresses, and shear stresses will always be there if there is a shearing operation. So tensile plus shear stresses will always be there, but if the shear stress is not mentioned in the question, then only write tensile stress. Wire drawing operation, tensile stress. Sheet metal drawing operation, tensile plus compressive, both. And in case of forging operation, compressive stresses will be acting. Now let's proceed to some of its types. Okay, now let's proceed to deep drawing operation. Deep drawing. This was thickness D, and this was the diameter. Let's say this is the diameter of the blank, and there is a punch whose diameter is, let's say, dp. Now deep drawing operation, what will happen in deep drawing operation? In deep drawing operation we will be producing shell like or cup like articles. In case of deep drawing operation, our from sheet metal we will be producing shell like or cup like articles. Now when we will call a process to be a deep drawing process, now if the height, that is h, which is if the height of the final product which is produced is greater than that of d by 2, then it is called as a deep drawing process. And if the height that is obtained is less than that of d by 2, then it is called as a shallow drawing process. Now what will be the force required for doing deep drawing operation? What will be the force required for deep drawing operation? The force that is required for deep drawing operation will be F is equal to L T tau, diameter of the blank divided by diameter of the punch, minus C. Okay, let me write it in next slide. Now L, what will be the value of L? L will be pi into D. Now what will be the value of D here? Here D will be punch, diameter of the punch. Therefore the force required in deep drawing operation will be LT tau, that is pi dp t tau, diameter of the blank divided by diameter of the punch, minus C. Now here dp, dia of punch, this is the thickness of the product, this is the shear stress of sheet material, shear strength of sheet material, this is the diameter of the blank, this C is what? This C is the constant in order to cover friction, constant to cover friction. This will range from 0.6 to 0.7. This will be given in the question. Okay, deep drawing operation is finished. Now what is a redrawing operation? what is a redrawing operation? In redrawing operation, we'll be having a shell which is already produced by deep drawing operation or some other operation. We'll be having a shell or an article which is already produced. In redrawing operation, we will increase its depth. So what will happen in case of redrawing operation? In case of redrawing operation, the height will increase and the diameter will decrease. That is, in case of redrawing operation, the height increases at the cost of decrease in diameter. At the cost of decrease in diameter. Okay. Now, now one important thing in case of deep drawing operation is that one important thing that I forgot to mention in case of deep drawing operation is that what should be the blank holding force in case of deep drawing operation? The blank holding force. What should be the blank holding force in case of deep drawing operation in order to prevent wrinkles? Okay, should be the blank holding force? The blank holding force should be 1/3 of the deep drawing force. It should be 1/3 of the deep drawing force in order to prevent wrinkles. Okay, now redrawing operation increasing the depth of a shell or an article which has been already produced by deep drawing operation. Here the height increases, that is the depth increases at the cost of decrease in diameter. Now ironing process. Ironing process, this is also a deep drawing process. This is also a sheet metal drawing operation. What will happen here is that here the height, that is the depth of an article which is already produced by deep drawing operation, will be increased at the cost of decrease in thickness. At the cost of decrease in thickness. Okay. So when it will be asked in question that which of the drawing processes controls the thickness, then it will be ironing process. Here the depth of the article which has been produced or cell which has been produced increases at the cost of decrease in thickness. It will be like this. Let me draw it for you. This will be the die. Forgive me for such poor drawing. This will be the punch. So let me draw. This will be the punch, and what will happen? The blank which was initially like this, no sorry, the shell which was initially like this will get very small. That is, height will increase but the thickness will decrease. Okay, so what will happen here is that here the initial height, this is the initial height, and initial thickness will be equal to the final height and product of final height and final thickness. That is, the product of initial height and initial thickness will be equal to the product of the final height and final thickness. So here if we are given with the initial height and initial thickness, and we are given it with any one of the final height or final thickness, then we will be able to find the other one by using this formula. Now let's proceed to the last drawing operation. Now the last drawing operation is reverse drawing. What will happen in case of reverse drawing operation? In case of reverse drawing operation, we will be having a shell. Let's say this is the shell or article which is already produced by deep drawing operation. So what we'll do here is that we will invert it and again punch it. Here this is the punch, this is the punch, this is the shell which has already been produced by some other deep drawing operation. These are the blank holders. So finally what we will obtain, finally we will obtain this type of product. Finally we will obtain this type of product. This is called as the reverse drawing process. Now let's study about the bending allowance. Now bending allowance will we sometimes they might ask us to find the bending allowance. There is a formula to find the bending allowance. Bending allowance can be found by 2 pi method. 2 pi method, that is, first write 2 pi, then there will be r, then there will be 0.5 t divided by 360 divided by theta, where theta will be what? Where theta will be bend angle. That is, if it is bend at 90 degree, then what will happen? If it is bend at 90 degree, then theta will be 90 degree. Okay, then theta will be 90 degree. Now this formula can be helpful in order to find both bend angle as well as bend allowance. If bending allowance is given and we need to find the bend angle, we can find from here. And if we are asked to find the bending allowance and bending angle is given, then we can easily find it. Okay, so now what is r? We know that r is the corner radius which will be given. T is the thickness of the sheet material, and rest are constant. Okay, this is an important formula, that is bending allowance is equal to 2 pi into r minus 0.5 t divided by 360 divided by theta. These are all important formulas for sheet metal drawing operation. I have covered all the formulas that are necessary for solve all the questions in case of sheet metal drawing operations, including deep drawing, ironing, etc. Now in the next video, all the important questions that have come from this particular topic in all the competitive exams in last 15 years will be covered. So please do subscribe and hit the like button.